Okay, so these notes are all about just combining like terms. So basically just says you can simplify an algebraic expression by combining like terms. This means to combine common variable terms together and constant terms together. So common variable terms would have the same variables. So x's go with x's, a's go with a's, y's go with y's, and so on. So you'll see what that means here in just a minute. So we're going to do the odds in these notes, and then you're going to practice with the even. So we're going to start with number 1. We have 3x plus 6x. So you'll notice both of them have an x, so those would be common terms. So you do exactly what the math says there. That says 3 plus 6. So 3 plus 6 is 9, and we just keep the variable. So it was an x here for 3x and x for 6x, so it just stays 9x. And that's it. All right, on number 3, you'll see that we have 9 minus 6w plus 5. So we have both variable terms and constant terms. So again, variable terms go with variable terms, constants go with constants. So I'm always going to start with the variable term. So we have a negative 6w. There are no other w's. 9 doesn't have a w, 5 doesn't have a w. So we're just going to leave negative 6w kind of by itself. So we're going to write negative 6w. But then we do have two constant terms. So our constant terms are, again, numbers without a variable. So we have a 9 and we have a positive 5. Both of those are constants. They don't have anything attached to them. And so those are like terms. We combine the constants. So 9 plus 5 is just going to be positive 14. So our final answer for simplifying that expression is negative 6w plus 14. Right, so very similar, number 5. Now you're going to notice that we have just some extra variables. So again, common variables go together. So x's are going to go with x's, y's are going to go with y's. So we want to start with x's first. It's not incorrect, but typically we start with the variable in alphabetical order. So x comes before y, so we put the x's first. So I will start with the x's. So we have a 5x. And then a like term, that's a negative x. That's actually a negative 1x. So I'm going to add that in there. That is a negative 1x. So anytime you see a variable without a coefficient, then it's an understood 1. And then we also have a positive 3x. So we're just going to put those all together. Again, we're doing the math that it says. So we have 5x minus 1x. So 5 minus 1 would be 4x. Plus 3x would be 7x. And then we're going to do the same thing with the y's. So now we have a positive 7y and a positive 2y. So we put those together. Positive 7 plus 2 would be positive 9y. So plus 9y. So our final answer in simplifying that expression is 7x plus 9y. All right, so next example, we have a couple of variables here, but notice they're all attached. So we have negative 4a squared b. That's one term. So negative 4a squared b is one term. So you should notice that it does have a like term down here at positive 10a squared b. So negative 4a squared b plus 10a squared b. The a squared b makes those like terms. So we're just going to do that math. Negative 4 plus 10 would be positive 6. And again, we leave the variable. So positive 6, excuse me, a squared b. And then we also have a constant in this case. We have a 7. It doesn't have any other constants to go with it. So we just bring that down with it. So variables go in alphabetical order, and then constants typically go at the very end. It's not incorrect, but that is typically how you're going to see it. Right, number 9. So this is similar. We have several variables here. So we're going to start with the a squared. Again, we want to start in alphabetical order with the highest degree. So that 2 makes that a the highest degree, where the 7ab and the 10ab, the a only has one of those. So a squared is the highest degree in alphabetical order. So I don't see any other a squared, so I'm going to write that and just leave it a squared. Again, that is technically 1a squared, so you could write that if you want. Normally, we would not write that one, but you might see it like that. So that is a squared or 1a squared. Then next, again, going in alphabetical order is going to be the AB terms. So we have a plus 7AB minus 10AB. So those are like terms. So 7AB minus 10AB. 7 minus 10 is negative 3, and we leave the variable a, b. And then lastly, we have a b squared term. There is no other b squared, so that just stays by itself. Again, that could be plus 1b squared. Again, typically we don't write the 1. You can if you want. It's not incorrect, but it is understood to just be b squared. So 1b squared or just b squared. All right, so those are all the odds on the first page. So now we're going to go to the second page. So number 11, very similar, just now it's kind of in the context of a picture. So it says determine the perimeter. So perimeter, you should hopefully remember, is just all the way around. So we're going to add up all of the sides, which is why they gave us all 3 sides. So you could write that out if you want, and I'm going to do it this one time just to show you. If I were going to write this out, I would start with whatever side. I'll start with the 17 minus a, so I would write 17 minus a. I would add the bottom, or the base here, 5a minus 1, plus the third side, 4ab. So I could write that out as an expression that's really long. Some people can see that without writing it out, so they don't actually have to write that, but it is a little bit helpful if you can write it out like that. So then you're just going to combine like terms. So if I'm starting in alphabetical order, that would be the a's. Really, again, that's not the only way, but that's typically how we're going to do it. So we would have negative a, again, that's a negative 1a if you want to write that, plus 5a. And that's it. The 4ab is not a like term because it has a b. So those are not alike. So basically we have negative 1a plus 5a. So those two would combine to give us 4a. All right, and then my next terms, again in alphabetical order, would be the ab terms. So I have positive 4ab, and I don't have any other ab's, so I'm just going to leave that. It's just going to be positive 4ab. Okay, and then I look, and my last 2 pieces, I have a 17 left, and I have a negative 1. Both of those are constants. They don't have any like term. I mean, they don't have a variable, so they are like terms. They're just constants. So 17 minus 1 would be a positive 16. So our final answer for the perimeter of this triangle would be 4a plus 4ab plus 16, and that's as simplified as we can make it at this point. All right, so again, very similar. Number 13, determine the perimeter of this trapezoid. So you could write that all out if you want to. It is completely up to you. This time I'm going to show you just a little bit different way. So I like to use highlighters. So if you have a highlighter, I would grab that. So we want to find the perimeter. Again, perimeter is adding up all the sides. So to do that, I just can find all the like terms, and I'm adding them together. So I have a k squared here, a k squared here, a k squared here, and a 2k squared here. Those are all like terms. They're all k squareds. Remember that where it's just a k squared right here, that's a 1k squared. This is 1k squared. This is also 1k squared. So if I'm adding those 4 pieces all together, I have 1, 2, 3, plus 2 more would make 5k squared. So those are my k squared like terms that I'm putting together. All right, so then my next would be the k's. So I did k squared first because it's the highest degree. Then I would go to the k's. So I have a minus 9k, that's important, minus 9k, a plus k, and a plus k. Again, those are 1k, so I'll add that in there for you. So this is a 1k and a 1k. So a negative 9k plus 1k would be negative 8k. Negative 8k plus 1k would be negative 7k. Basically, that's negative 9 plus 2, because 1 and 1 makes 2. So negative 9 plus 2 would be negative 7k. And then the very last piece is to combine the constants. So our constants here, hopefully you already know what they are. The constants here are a positive 23 and a negative 17. They don't have any variable. So 23 essentially minus 17 is going to be positive 6. So 23 minus 17 will be positive 6. So our final answer for the perimeter of this trapezoid would be 5k squared minus 7k plus 6. All right, last odd. So this is more of just a word problem. Still goes with a picture. I would definitely draw it. It says, excuse me, find the perimeter of a rectangle that has a length of x plus 2 and a width of x minus 5. So the first thing I'm going to do is I'm just going to draw a little picture here. So I have a rectangle. Okay, and my rectangle has a length of x plus 2 and a width of x minus 5. So what you should know about a rectangle is that opposite sides are equal, so are congruent. So this side would also be x plus 2, and this side would be x minus 5. So I'm finding the perimeter of that. I'm just adding up all of those sides again. I'm adding all the way around. So to do that, I would again find the like terms and combine those. If you wanted to write that out into a sentence, absolutely fine, but I would just add the like terms. So I have a 1k, a 1x, another 1x, another 1x, and another 1x. So all together, I have 4 x's. So that would be 4x. And then my other pieces are all constants. So if I have a constant of positive 2 and positive 2, you might want to write that out. That's 4. And then you have a negative 5 and a negative 5. That would be negative 10. So 4 and negative 10 would make negative 6. So the perimeter of this rectangle would be 4x minus 6. All right, so the evens, I would like for you to try those, and then we will go over those in class. If you have any questions, feel free to come in, but we will absolutely go over these in class.